Okay, so we are going over an example of exponential decay. So this is just one of the problems off of your quiz, and most of the problems look very similar to this. So the situation is a hiker in Africa discovers a skull that contains 51% of its original amount of C14. And then we have this nice little equation here. N equals N sub 0, that's how we read that, times e to the negative kt. And it tells us what each of those things mean. So N sub 0 is our initial amount of C14 at time t equals 0. So like the very beginning before it was found. N is the amount of C14 at time t. They give us k, which is 0.0001, and t equals our time in years. And our question is, find the age of the spearhead to the nearest year. So we want to find out how old was that spearhead. And let's see, let's do some green highlighting. So we want to figure out what t is. We won't know what that is. So I'm going to put like a little question mark next to that. Okay, let's go back to N sub 0. So right here. Initial amount of C14. So when we found the skull, it had 51% of its original amount of C14. So that means at the very, very beginning, that skull had 100% of its C14. And how we write 100% as a decimal is 1.00, or you can just write it as 1. So our N sub 0 is 1. And I think that's the trickiest part of this whole thing. Our N is the amount of C14 at time t. So I'm going to write this in, let's do red. So the amount at time t was 51%. But we want to write that as a decimal, so that is 0.51. And then we have our k, which is 0.0001, and we're looking for our t. So all we need to do is plug all of those numbers into this equation that I highlighted in yellow. So this guy up here. So I'm going to go ahead and do that. So we have n equals, and our n is 0.51. So I have 0.51 equals n sub 0, which is 1, and then times e to the negative k times t power. Well, we need that negative up here, and then k is 0.0001, and then times t. And we don't know what t is. We're looking for t. Okay, so our first step is we want to, first of all, our goal is to isolate that t. We want to get t all by itself. And right now it's really inconvenient because it's in our exponent. So we want to get it out of that exponent. That's our goal. But first, what we need to do is we need to get this e to the negative 0.001 times t. We need to get that by itself. So we first need to divide by whatever number is being multiplied by 1. I'm sorry, by e. And in this case, it's 1. And it seems a little silly to divide by 1. It's not a necessary step. But we're going to go ahead and do it anyway. So those cancel out, the ones. 0.51 divided by 1 is 0.51. And that equals e to the negative 0.001. And I'm going to even put a little multiplication sign here. Oops. I missed a 0. 0.0001 times t. So our t is still in that exponent, and we really, really don't want that. So we need to get rid of that e and bring that exponent down. And in order to do that, we need to take the natural log. So I'm going to take the natural log, it's ln, of both sides. So 0.51, and that equals, I'm going to take the natural log of this side as well, of e to the negative 0.001 times t. And for this, you do need a calculator, so I will show you the one I like to use. So I'm going to go to Google. And you can use this too on your computer, or you can download it as an app on your phone, but it's called the Desmos Scientific Calculator. So this guy right here. And it's the first one that pops up on Google. And it looks like this. So if you want to pull that calculator up, or if you have a calculator at home, don't use your iPhone one. Okay. So first what we need to do is we need to take the natural log of 0.51. And I'll show you that real quick, because that's going to give us a decimal number over here on the left. So we're going to put this in our calculator first. Okay. And how we do that on here, the natural log is under functions, and it's right down here. So I'm going to take the natural log of 0.51, and I get negative 0.6733. So I'm going to simplify this right here, oops, to negative 0.6733. And what the natural log does on the other side is these actually just cancel out, the natural log and the e. And guess what? That allows us to bring that exponent down to the ground. I forgot another 0 over here, sorry. Times t. And now all we have to do is isolate that t. And we just have to do the inverse operation. So right now t is being multiplied by negative 0.0001. So we need to do the inverse and divide. So we're going to divide both sides by negative 0.0001. Divide by negative 0.0001. These cancel out. And whatever number this over here gives us, that will equal t. So we're going to use our calculator for that again. So I have negative 0.67, oops, negative 0.6733. And we're going to divide that by negative 0.0001. And I get 6,733. That's a big number. 6,733 equals t. And I'll make this smaller so you can see it. And guess what? That's one of our answers up here. Okay, so pretty much every single question that you do on this quiz is going to look exactly the same as this. So I'll make it a little bit smaller so you can take a picture of it, write it down somewhere, and follow these same steps for the other problems.